everyone, I am Niyati Shah. I am currently pursuing Masters in Construction Engineering and Management from SAPT University. As the part of our Studio 3, Integrated on Construction Practices, we have undertaken the study of mixed use project. This studio focuses on application of BEAM and lean practices. Coming to the next slide. Major details regarding the project are the project is mixed use residential plus commercial project. The cost of project is 180 crore. The type of contract is labor rate contract. The built up area is 1,10,934 meter square. It is located in Wapa, Ahmedabad. It does have 2 basement plus ground floor plus 14 floor. There are in all 8 towers, out of which we have considered C and F as for our scope of work. In this studio, each member have played a role of key stakeholders to simulate the process of BEAM implementation. For the same, I, Niyati Shah, have played the role of contractor and plumbing consultant. The major responsibilities for that are site optimization, quantity takeoff, 4D and 5D simulation, LOD 300 plumbing model, and model coordination. The flow of presentation will be, first I will be explaining the integrated construction practices process map which we have implemented for our studio, site layout optimization, 3D BIM modeling, 4D simulation, 5D simulation, LPS, and the major key learnings. To the next slide. This slide is regarding the ICP process map which has been followed in the studio for our project. It starts with getting client's requirement, formulating BIM execution plan with respect to the client's requirement, i.e. that is employees information requirement. According to the BIM users and employees information requirement, preparation of LOD 300 models which consist of architectural structure, MPF. After preparation of that, again then there will be the clash detection, clash coordination and clash resolution process has been done. We get clash free models. From the clash free models we were able to obtain the quantities by which we were able to compare the manually calculated quantities and the Revit calculated quantities. After that, LOD 400 models have been prepared for the architecture and structure. Again, integration is done between the LOD 400 architecture and structure, LOD 300 MEPF model, and LOD 400 structure model has been done. Again, clash detection and clash resolution has been done. Then quantity takeoff has been done for LOD 400 models and LOD 300 MEPF models. After that, 4D and 5D simulation has been done, and we get to understand what are the advantages of this process map at the end of the studio. The major advantages, because due to the adoption of this process map which we have observed throughout the studio, is that first there is this increased visualization on the project has been found in terms of 4D and 5D implementation, 5D simulation which we have implemented on the project. There is an immense amount of time and cost savings in the terms of coordination, collaboration, because the collaborative approach that has been adopted in this process by creating the common data environment and by coordinating along with that, standardization has been also been observed. All the stakeholders does have aligned goals because all the BIM uses, all the procedure, everything has been standardized in the BIM execution plan, which fixes that this is the goal, this has been done throughout the studio. Because of the early involvement of the stakeholders, improved coordination has also been found. slide, which is site layout optimization. As you can see, this is the current state. These are the 8 blocks. Here labor sheds are located. Here batching plant is located. Here contractors' offices are located. Here marketing office is there. Here material storage is there. Here quality laboratory is there. Here there is a material storage. Here there is a go down. These are the toilets. Here the parking has been done. These are the debris which has been accumulated over the period of time. Major pluses are the client's office is located such that there is easy access to the construction site. There is separate entry for laborers and material. So this two entry are for material. From here, the entry is towards the marketing office. This is the entry from where material as well as labors come from. Batching plant is such that it eliminates the need of having transit mixture for the transportation of concrete. Majorly data which has been noticed is that the unorganized scrap has been observed here. Steel yard is haphazardly placed. There is no systematically placement of steel yard. Drinking water facility is just single. It is not provided on the site. It is provided beside the site, and there is only singular point. Also for washroom facilities, there is a restricted movement on the site as well. In the future state, the distance between the labor shed has been increased, which were not sufficient and which caused the risk of to fire, risk to unhygienic condition which could have been created. The steel yard has been properly organized. There were boxes which has been placed for proper placement of steel scrap bars according to the dia and according to the size. Here, toilet has been located in 2 places, here and here. Security cabin has also been provided for the increased safety. Separate cooking area is provided which increased the safety, enhanced the safety on the site, because there was no cooking area, so it lead to increased fire exposure as the labor sheds were very closely placed. Drinking water facilities has been provided twice. Here also the drinking water facilities there, and in the block also the cement godown which was located here, which was creating the motion waste, it was shifted here so that the time wasted in transportation and motion waste has been reduced. The major inference which we have obtained from the site layout is that there is a reduction of waste which was caused due to unnecessary motion has been observed, which was reduced, and safety measures have also been enhanced in the terms the distance between the labor shades. Coming to the next slide, 3D beam modeling plumbing model, which has been done by plumbing consultant. This is the process map which has been followed by the plumbing consultant, which has been standardized in beam execution plane. It starts with identifying the model elements from the 2D detailed drawings which has been provided. Then LOD 300 modeling preparation has been done by integrating LOD 300 structural and architectural model. The modeling of plumbing modeling till LOD 300 has been done in the plumbing template. Then the visual checks has been done by the plumbing consultant. If yes, errors are there, then it has been resolved. Again checked is done. If no, then it has been shared in the Google Drive, which is the common data environment which has been created for the implementation of beam. Then clash detection has been done. If there is no clash detection, then it has been again shared on the clash free model has been shared on the common data environment. If there is clash, then it has been resolved, and then it has been shared on CDE. This is the end. On the right hand side, as you can see, this is the structural model, which is in which there is this integrated plumbing model has been created. These are the various model element which has been created. There is AC drain pipe, rainwater pipe, single stack pipe, domestic water supply, soil pipe, hot water supply. There are various other elements as well. Geyser is there, P-trap is there, wash basins is there. The major constant which has been observed for the plumbing consultant is that the plumbing consultant is also a contractor. So in the week 9, the individual PPC reduced to 33%, because in that week the plumbing consultant as well as contractor both has committed to the work, which led to the delays. Coming to the next slide, which is 4D simulation. Observations on contractors' organizational planning and monitoring system were done. From that, we were able to conclude that there is schedule tracking but without visual assistance is there. We linked the 3D BIM model with the schedule using Synchro 4D to aid the visibility constraints. The following is the process which has been followed, which has been given below. As can be seen, first of all, the observation has been made, problem statement was identified, which is a visual assistance is required. Developing 3D models with project parameter, which is parametric project parameter in the Revit with the help of detailed drawings that has been obtained. It has been integrated, or a schedule is being prepared with respect to that shared parameters, and the model is linked with the schedule in the Synchro. 4D simulation is obtained and we can track the project progress in it. The scope of work which we have taken for the 4D simulation is C and F block 7th to 10th floor. As you can see, the ongoing construction activity is basically the RCC work, which includes column shuttering, reinforcement, concreting, slab shuttering, reinforcement, concreting. Except for the slab concreting, everything is done in two parts as shown in the figure. The area of one part is 852.65 square meter, and the area total area is 852.65 square meter, and part 1 is 403.49 meter square and 449.16 meter square. All the fours are typical. Coming to 4D simulation basically involves comparing the actual progress of the construction activities with the planned schedule. The figure, there are two instances as shown. The instance 1, as you can see, it is the F block, it is of F block 8th floor. The activity is slab staging and shuttering. This is the plan and this is the actual. So planned start is 6:10 and the actual start is 8:10. So we can see the date on which it has been done. That is the deviation which we can observe. Again, this is the second instance where the task is reinforcement. Plan start is 24:09, but actual start is 26:09. This can be seen from this figure. From these instances, we can say that real-time progress tracking can be done. Along with that, we would be able to analyze whether the schedule is ahead, whether we are ahead of schedule, behind the schedule, or on the schedule. As you can see in these two instances, we can find that the activities which has been planned for 3 days has been completing in 1 day. It also shows we would be able to analyze further in the terms what were the reasons behind that. The major reasons because of that which activities were delayed here is because of unavailability of labor, and here because of the unavailability of material. So it also aids in visualization in terms we were able to see what was the actual progress. We were able to analyze why we are ahead, behind, why the activities are being completed in one day instead of 3 which has been planned. Coming to the next slide, which is 5D simulation. So 5D beam modeling is specifically refers to the integration of 3D beam model with the time and the cost. On value analysis has been done to measure the project performance at given point of time. Basically, there are three parameters. There are three values which we should know. The one is planned value. It is the budget which has been allocated to the scheduled amount of work. Earned value is the budget which is associated with the authorized work which has been completed, and actual cost is the actual cost incurred in accomplishing the work which EV has measured. Looking at the overall project performance, we can look at cost there are two index and there are three values we have obtained. There is cost performance index and schedule performance index. Both are less than 1, which indicates that there is delay in the plan schedule, and CPI is and also there are cost overruns. This is the overall project performance. Now if we talk about gradually for 6 weeks, we can look at initially the CPI was 0.74, which is very low. The schedule was the actual condition and actual progress were far behind the scheduled one. It gradually increased and reached to 1.02, which shows that the project is trying to match the schedule. But in the same 6 weeks, we can see that the CPI is almost the same, which shows us though the schedule is trying to match, the project is trying to match the schedule, but the actual costs are still above the budgeted ones. Coming to the last planner system, the last planner systems aims in increasing the planning reliability. Last planner is someone who performs the work. In here, first of all, master schedule has been prepared from where the milestone has been set. From that, phase schedule has been prepared, which should be done. It is normally of 4 to 6 months. From that, look ahead plan has been prepared, which can be done on the basis of constant analysis. From that, weekly work plan is prepared, which is the commitment taken from the foreman, and after that the percentage plan complete has been obtained, which indicates what was the work did as per the commitments taken from the foreman. The scope is taken as FNC. Scope of work is 7 to 10 floor, and ongoing activities is RCC work. Your process which we have followed is that we have observed for 6 weeks. For the first 3 weeks, we have observed traditionally tracked the schedule, and for the last 3 weeks, LPS implemented. For that, we have prepared the look ahead plan. We have done constant analysis, and weekly work plan has been prepared on the basis of the commitment, and PPC was tracked for all of the 6 weeks. Coming to LPS implementation on site, from our observation, it has been found that for first to 3 week, 1 to week 3, where the activities are traditionally tracked, the PPC obtained was 100%. We have noticed that because that there were few of the activities which were planned for 3 days, but it was done in 1 day, which indicates excess time is available for the individual task, including buffers. That is the reason. What happens in such case, underestimation of the task has been done. After that, LP has been implemented for 4 to 6 weeks. The activities which were completed, which were having 3 days and was completed in 1 day, was given 1 day. So slab cycle having 14 days has been 14 days is now been reduced to 10 days. From that, we understood that we have pulled the activities which could be done on the basis of the commitments which were given by the foreman. After that, after preparing cycle of 10 days, we were able to see that PPC dropped from 100% to 81%, but progressively increased to 90%, which infers that Workflow reliability has been increased because of the commitment weekly which were taken from the foreman. Continuous improvement can be seen in the sense from the 81% is increased to 90% PPC has been increased. Collaborative approach can be seen in the terms that discussion and taking commitment from the team from the bottom up approach, which shows that workflow reliability has been also been increased. During LPS implementation, the major reason of variance which were obtained was the unavailability of labors, unavailability of material, external factors includes the sudden electric power cut down. Coming to the next slide, which is key learnings. Last planner system, which were able to understand collaborative approach, bottom top approach, increases the workflow reliability, increases the planning reliability. We can be able to detect the early constraints. From the 4D simulation provides a better visualization, real-time progress monitoring can be done. Also, it facilitates decision making on the terms of project progress at any given time, what should be done after that. Site layout optimization maximizes the space utilization, maximizes the efficiency in terms of space utilization. It increases enhance the safety measures. Reduction in waste in the terms of motion waste has been observed by after site has been optimized. 5D simulation, from that we learned that it facilitates the project performance measurement. Early problem identification can be obtained from the indicators like CPI and SPI. Forecast also can be what future performance can be seen like. From that, decision can also be made. Accurate and quick cost estimation can also be obtained from the 5D simulation.